Hello and welcome to this video about how we combine sockets and multi-threading in order to handle multiple clients. So that's the goal. Alright. And we will hopefully end up with a simple console chat system so that I can start multiple clients and I can write in the console and that should show up at the other clients. So it will look something like this. I have my server and the server has a socket and there's a client and you can connect. Right. And then I also want to be able to send a message to the server from the client and we send that back. So this is sort of what we achieved last time. And today we will expand the example with the possibility to send to the other clients here. So when one client sends a message to the server should then make sure that they are all sent, well, the same message is sent to all the clients. So that's what we are aiming for today. So I have some code that we will just go through. It's just the simple to uppercase echo server that you have seen before. Let's take a look at that, and I have it here. Let me open that one as well. So the server, I will start the server socket in the while true so that we can connect one client and then handle the next one and handle the next one. So after each client is finished being handled, we will move on to the next one. So I accept a client connection. I create my streams, input and output, to read and write objects. And then the protocol is that we expect a message from the client, we print it out on the server, we make that message to uppercase, and then I send it back to the client. So that's about it. For the client side, we will create a socket connecting to, in my case, local hosts on this port, the same port as the server. I will create the streams object input and output. We have here the message to be sent to the server. I write that to the server. I take my message here, I wrap it inside a message object and I send that to the server. And then I expect to get a result back again, which is the uppercase of what I sent, and I will print this out. And then the message object here being sent back and forth, it just contains a string and a get method to retrieve it, and then it must implement serializable. So only serializable objects can be sent across the network. And if I implement serializable up here, then all of my field variables, if I had other field variables here, they must also implement serializable. String does that, all your symbol type does it, your array list and other collections does it. So you shouldn't run into any problems. If you create your own person class and you want to send that as well, then the person must also implement serializable. So that's our current setup. Let me just run everything. I run the server here, and the server is started. Close this, and we start the client, and that should just send hello again, and then print out the result when we get that back from the server. And we're sending hello again, and we get an uppercase result back, and the server, I got established the connection, and well, I'm printing out, so you see here, I'm printing out some strange text here, and that's because I'm not printing out the content of the message, which I probably should, like this. I'm printing out the actual object, and if there's no what's it called, to string method, then it will just take the object ID or something like that. So I can auto generate it to string method, which will print out, it looks like JSON format, so it will print out what the content is. Okay, so that's our current setup, and I have made it so that my server is still running, right, because there is a while true loop. So when the first client is handled, it goes back and accepts the second one. And if I run the client again, it will be a new client, but the same server. So it just has to compile again because I changed something. Here we go. And that's interesting. Hang on. Okay, that's because I changed the message class which is what the client sends, but the server was still running, so it had the old message class. So I just need to restart both programs. Okay. Yep, and the server is running, and I can run the client again. It will print out a new, and the server has received something twice. Okay, so far so good. So that's what we achieved last time. Let me just shut down everything. All right. So now I want to expand upon my example so that the client takes input from me, and it doesn't just send a message once. I need it to keep running. So instead of sending this one here, so I make the initial connection and I make my streams, and then I want this part to repeat, and I will just need a scanner to get something from the console. Scanner system.in, like that, and we say in.read next line. That should give me a string, and that's what I want to send, and then we get something back, and after that then I want to repeat it, right? So I just want to Control-Alt-T to get this menu, and I can just do surround with. There we go. And for the echo server, right, so now this is repeating. I make the connection once, and I keep sending stuff. For the echo server, I want to do the same thing, so I accept the connection, I have my streams, and then this part is what we want to repeat. So Control-Alt-T again, and this, and then we should also have it so that we can exit. So if what I receive here, read from client, get message equals exit, I just equals ignore case. Then we want to break. I probably want to say, yeah, let's see how this goes. And if this one here is, if arc equals ignore case exit, then we want to say socket dot, I want to close it, and I want to break. Okay, let's see how this turned out. All right, so my server is running. Let me start up my client. Oh, maybe I need to, hang on. I will just do like this, so I can see that I'm supposed to put something in. Let's try again. All right, so my server started, and I started my client, so there's a connection, and I should input something. Hello, and I get it back in uppercase. Good day, and I can keep writing. Let's see how this goes. Exit. So my client shuts down, and my server is now ready for the next client, so I can run this one again. And say I am next in line. We get that back. Hello again, and so on. So if I type exit, that shuts down, but my server keeps running and is ready for the next client to be accepted. So I think we've gotten to a point here. So I have a fairly simple to uppercase system, and I can keep sending messages and keep getting them back again. Now I do have a problem, and let's just take a look at the next step, because right, we'll do it here. So my server here is my server, right? My server will be stuck in this line here with the accept method until a client connects. Then it will create the object streams, and then it will be stuck in a while loop until that client sends the exit. we also stuck here until the client sends an object. So the read object and the accept methods, those can halt the program. So that means currently I can only accept one client, and then we're stuck in the while loop. And if I try to connect with a second client, it will have to wait until the first client is finished. And then we can serve the second client. So only one client at a time, and obviously that's not a very good approach. That's what we're going to fix today. But let's just see what happens here. So I start my server and I start my client. Yeah, and I pause it there, I don't do anything, and then I want to start a new client. And okay, so it's not allowed to run in parallel. And remember that I can go up here into configurations and click the allow run in parallel for my echo client. Okay, let's see if that fixed anything. Yeah. Okay, so now I have a new client that's also running. You can see it's running, but it hasn't printed out the input here. And that's because it's stuck in the connection. It hasn't connected to the server yet, because the server has only accepted the first client here. So if I say hello, I get that back, and my client here is still doing nothing, and my server has received hello. For this one, the active client, you might say, if I click exit, this one shuts down, and now we can see the second client has been accepted. Right? In my server side, the first client was accepted. We're stuck in the while loop until the first client sends exit. Then we break out of the while loop and we go back and accept the next client connection, which is then this client here. Hello from other client. I misplaced my hands apparently. Jeep. And we say exit, and that also terminates, and my server is still running. Okay, so that's what we have achieved so far. That we can handle one client at a time, right? So my client is stuck with the accept method, and we also stuck at the read object method, and then I also had the while true around the part with reading objects, so we were also stuck in the while true. So we want to expand our example so that we can handle multiple clients at the same time, and this is how it's going to work. I still have my client. Here we go, my client and my server. My client will connect, so that's the welcome socket.accept or server socket or whatever you call it. And the idea is now that we use a new thread. So the socket instance that I get out of the accept call here, I hand that over to a new thread, a class that I make and run in a new thread. And then this thread is responsible for interacting with the client, right? So for each client that connects, we do this part here and spawn a new thread, and here's the communication between client and server primarily going on. And my server is now just responsible for accepting a connection and spawning a new thread. Then we're ready to accept a new connection and spawn a thread. So this just takes a second, a millisecond or two, and then we're ready for the next connection. So now I can connect many clients, and each client is handled by a separate thread. So after each thread has been spawned, we go back and we are ready to accept the next connection. So let's move on to next part of the example. We will add multi-threading to the server. Now at some point I need the clients to sort of interact. When one client sends a message to the server should send that message to all clients, but we won't do that yet. We'll take it one step at a time. So multi-threading on the server side, that's the next step. So let's see how that goes. Okay, so I need a new class. Let's just organize this a little bit. So I'll create a client package and put my echo client in. Yeah, refactor. I will create a server package and put my echo server in. Yeah. And I will create a package which I call transfer objects. So this package contains all the objects that's used to send data back and forth. In my case, I just have the message, but maybe you have other stuff. For when we get to remote method invocation, you're going to have many different transfer objects. If you just use sockets, you may not. Maybe you just have one, but yeah, that's up to you. But I have organized my code, and now the server here. So the idea was that instead of handling the communication with a client here I would do that in a separate thread. So whenever we accept here, let's do it here. Here, spawn new thread with socket instance, right? This socket here. And then all that stuff goes on in the other thread. So let's create that. I call it server socket handler. It implements runnable because I have to run it in a separate thread. I have to implement the run method. There we go. So my this class here needs a socket instance, and that's given to it from the server here. So this socket instance must be handed over to the thread. So I create a constructor with that socket instance, right? We're taking a socket as a parameter. All right, then all this stuff here, that I put over here into the run method, so that this is now executed in a separate thread. And all these, so I need to put a try catch, Control Alt T again, put a try catch around everything, and I can collapse these two here, this one. All right. So that should sort of be it. I have the same behavior. It's now just handled in a separate thread. So I need to handle that here, and we say a new thread, and it contains a new server socket handler with my socket. There we go. And I actually want to start the thread. So that should be it for my server, right? The client will connect, we get a socket, we hand that over to a new thread, and we start the thread so that communications with that specific socket is handled in this thread, and then we start over and accept the next one here, over and over. Okay, let's just clean up a bit. Here we go, and you'll need that one. Okay, so that's the idea. Now the question is whether it actually works or not. So let's run the server. And my server is running. I start a client, and we see I get the input, so my client is ready. I start another client, and that's also getting the input here. So both my clients are ready, and let's just pick a third client here, and that one is also ready for input. So I'll just take my second client, and we say hello, and I can actually get something back, and it's ready for the next one, and also hello from here, and that's wonderful. And the third one, do I also work? So yes, I do. How wonderful. Right. Okay, so my server is handling all of these. It's still printing out that it receives stuff through the clients. Right, that's printed out from the thread, from the server socket handler. So this works according to plan. I can call the exit, and that terminates, and my server is not crashed or anything. And I call exit here, that also terminates, and exit on the last one, exit, there we go. And received exits, and my server is still running, ready for the next connection. So that's all well and good. So we now have this part in place. Oh, almost. Right, so this is my current setup. The client connects, we spawn a thread, and now the interaction between client and server is handled through this thread here, and my server is just responsible for accepting connections over and over. All right, so next step, right? This would be the next step. So I have handled that each client is handled in a separate thread on the server, right? My server connections here, my server socket handler. None of the clients are blocking for each other, so they can all interact with the server without blocking for each other, but we still just have the uppercase echo thing. So what we want to achieve next is this part here, we'll get to that, but if one client sends something, the server must send that back to all the clients, right? So that's really a strong feature in a chat system, fairly necessary if you have a chat system you want to be able to chat with others. All right. So the idea is that I have this class that holds a list of all my connections. Right. So whenever a server thread receives a message, we use that class to broadcast that message to all the other clients. And now my clients must listen for messages coming from the server unexpectedly. Currently, we definitely expect a message. Whenever a client sends a message, it expects to receive one again because that's our protocol. But now the client can receive a message without having sent something to the server, so it's, you might call it asynchronously now. And this is the idea. I have this class, my list of connections, my pool. So the server is running, right? That's the timeline of the lifeline or whatever. The client will connect and spawn a new thread, and that thread or server socket handler object is put into the connection pool. Right. My other client will also connect, is put into the pool, and a new thread is spawned, and the third client connects. That is also put in the pool. So my pool here is now a list of 3 connected clients, and it's handled in a new thread. And so all the threads are running on the server. I have my connection pool with a list of all my connected clients or their threads. Whenever a client sends a message, we want that message to be sent back. Maybe not to the client itself, but I'm not sure I want to handle that today. You could give each client an ID or a name and then just check who you're sending it back to. But that's not the point for today. Right? So this is the case that we want. My clients are interacting with the server through a thread, and those are all connected to my connection pool. Or my connection pool has a list of all my server socket handlers. So the next step is to make this connection pool. We want to make sure that the clients are ready to read a message whenever the server sends a message. Right, so my new and improved system will look something like this. Currently I have my socket server in a main method, but I actually prefer to just have a main method that will start another object. It's just a convention of mine, I guess. So I will create these 2 classes, and then we'll just create a new instance of socket client and call a start method on it. Not a separate thread necessarily, just to start it. I have my server socket handler, and now I'm going to need a client socket handler. So the server socket handler is listening for messages from the client, and my client socket handler will listen for messages from the server. And I have my connection pool down here to broadcast things, and my transfer object over here. These 2 are threads implementing runnable. So this is the system that we want to set up. Okay, let's see how that goes. So I need my pool. Let's just call that could be called server model, or I call it connection pool, but it is basically your server model. This one will need a private list of type server socket handler connections. And I might as well instantiate that right away. There we go. Okay, I need a method to broadcast. Right, so public void broadcast message with a capital M. There we go, message, and this is what I want to broadcast. And then I want to loop through my list here, and for each of them, like this, connection handler. I need a method to say send message. This one here. So I don't have this message yet. That's on the server socket handler that I need to create this. But this is basically what I need. It maintains a list of these guys, and I can send messages to all of them. I might also need a public void add handler, server socket handler. and we say connections add handler, and I might need to remove them again. Remove handler. Server socket handler. If one of my clients shuts down or terminates or whatever, then I don't want to keep them in the list of connected clients, because I'm trying to every time send a message to someone who is disconnected, and if this was actually going to be a large program with many connected people, then this list will grow very large. So I just want to maintain the list of currently connected clients. Okay, so we'll wait with this one. In the echo server, I need to create this one here. Yeah. Connection, pool, new one of these. Okay. Now, before I move further in this one, I wanted that separate main method. Right, here we go. So just these two to run them with just the main method. So I'll just do that. I'll just create a run server. So it's sort of similar to when we do the JavaFX. I also have a run application class. It just does nothing else than starting things up. Echo server, like that, and I create a start method on this one. There we go. Right, I create a start method. So I have that down here, and I will put all this in my start method, and I will remove that one. There we go. This one here, we will add some exceptions, and we will add exceptions here. That's just the easy one. Okay, so now I have a main method to just start my system up. So I don't want to put all kinds of stuff in the main method. That's just for initiating things. All right. So this pool here, whenever a server socket handler is started, like this, I need to put it into the pool, add handler. I also need to make sure that my server socket handler knows about the pool, so it can actually use it to broadcast things. So so now it's complaining about the second argument here. I can just alt enter to quick fix that, and that's added to the constructor. There we go. So that's what I need to do for my server part. We still accept the client. I create a new server socket handler, and it knows about that specific socket and the pool. I add the client to the pool, and then we can start the thread. So let's go to this one here. Right, so you see that the pool is now added as a second argument. We have a private connection pool, and we say this pool is equal pool. There we go. Okay, so now I want to split out the reading and the writing of my thread here. So currently I'm reading and writing in the same part, but the part inside the run should just read from the client and react to that. And then I need a separate method here down here, which would public void send message. This is the one that my connection pool needed. Right. So let's see if that fixed anything. Send message. Okay, so I need to rearrange a bit. Now for this, I'm going to need my out to client. I may need it in here. I definitely need it down here. So I'm going to put it into the constructor and instantiate it up here. I'll do the same thing for this one, just to be consistent. There we go. And I create a field of that. Yeah. And I create a field of that. There we go. And these are, I don't know, we'll just surround with a try catch here. And I'll remove that. Okay. So my run method should read an object from the client, and it should then I don't want to uppercase it anymore, that's not interesting. Then instead of sending it back to the same client, I will say that my pool, broadcast message here, read from client, get message. So this is what I want to send back again, right? If I get the exit, then my client has shut down and this server socket handler should also terminate. So instead of, well, I still need to break out of the while loop so that the run method just terminates down here. But I also need to say pool, remove handler, this. Right, so I need to remove myself from the connection pool so that other clients do not try to send something to the client that has disconnected. Okay. Now we need to be able to send something back. Whenever the broadcast message method is called, this send method will be called. So I need to send something back again, and we say out to client, write object, new message, image message, like that. And we need to surround with a try catch. There we go. All right. Now a small side note here. My connection pool is, you might consider this server logic, and currently it knows directly about server connections. I could make this a bit more loosely coupled if the connection pool was a subject, and whenever a message was added, it would then fire an event, and my server socket handlers would listen to the event and send a message. That means that my connection pool or my server model here does not know about the networking layer. That's also outside of the scope of today. We'll talk about that later on, but I just wanted to make a note about it. Right. So I think we are almost there on the server side. My server accepts, and we have the pool, and the pool can send messages, and my server socket handler should read a message and send it back again down here. So I think that's good. Now for my client side, we need to do something similar. So I have that separate thread to read input from the messages from the server. So we need to create a client socket handler, and it also implements runnable. There we go. And implement the run method. And this one also needs to know about a socket. So private socket. There we go. And I need a constructor for it. Constructor. And this one is it should just be used by the client. So it has a method that says send message. And it must also, whenever it receives a message from the server, it must hand that over to the client so the client can decide what to do with that message. So I also need to know about the echo client here. At some point I should call it something different than echo, I think, but that will be later. Client. That should not be an object like that. Yeah, okay, there we go. And this is the void. All right, so I need to do the same thing with the input and output streams. I'll just steal these guys. And I'll steal the other part, this one here. Yeah. And just swapping these around for good measure. All right, so the run method here needs to be a while true because I need to keep listening from the server, and we say in from, maybe I rename this, in from server out to server. There we go. And we say in from server, read object. That didn't go well. So the in from server is an input stream. This one there. And this one is out to server. That's the output stream, sending something out. Okay, so now I can read an object. And I know that I don't get an object, I get a message object. That's what I'm sending around. Yeah, I want to import that message. And I need to surround with a try catch. And what people often do here is just surround it like this. And I noticed that the try catch is inside the while true loop. So if my connection breaks, I will try to read from the server. It will fail. We will throw out a message here, spit it out. We will while true. We will start over and try again. It will fail, spit out, start over, fail, spit out, and so on. So I want the try catch to be outside, like that. Come on. Okay, yeah. We can collapse these. Now, the message received here, I need to give that to the client. So I have my client. Message received, and the client can figure out what do you want to do with that. You want to see that I'm not giving the client the message object, because that message object is just supposed to be used between the client and the server connection. So my client needs to get the actual content of it. So I will do like this, and I just want to print it out. And you may think I should have done this. I could just do it in my socket here, but we're preparing for a slightly larger system for next time, where we think about the responsibilities. So whenever the socket handler here gets something from the server, it's up to the client to figure out what do I actually want to do with that thing that I got from the server. Currently it's always just a string, but it could be all kinds of things. Alright, so we can read something from the server and we print it out. I need to also send something out to server, write object. And you will see I am also just giving it a string message here, and then I'm putting that into my transfer object. So new message object with message, and we need to surround with a try catch. There we go. Right. So again, it's to isolate things. My client does not need to know about the transfer object, so it just cares about the actual data. And then it's up to my client socket handler to figure out how do I want to send that data. So we have the isolation here and separation of concerns. So the send message method, that should be used from the client. So this should be it for my socket handler on the client side. Now we just need to use it. So I don't need these anymore. I need to start a new thread right away. We say client socket handler new, that one, and we give it a socket and we give it this. Right. So this is also it's complaining because I'm running in a static context, so I don't actually have this object. So that's why I need the run server, and I also need a run client. So let me just do that, run client. And this one will have the main method, and we have an echo client and a start method. So now I actually have an instance of an echo client. I need to create that one, and I will just put that up here and throw that. That's fine. I need to throw it here as well. Okay, so now I have I actually have an object that I've called this on the start method. So I have an instance of echo client that I can give here. I need to start that. So we say new thread with my handler, and we start it. Start. Okay. Then I don't have this anymore. I shouldn't write here. I should write handler send message, the argument. And if the argument is that, we shut down. And I need to make sure, because I can shut down my socket and stuff, but I might as well make sure that my thread does not stay alive for some reason. So we just say this one here. I need to make that a set daemon true. Right, so this thread cannot be alive without other threads. All right, I don't have this anymore. We have that down here. So now my client is responsible for taking my input and giving that over to the handler, which will then do whatever with it. And we're also responsible for receiving some input and print it out. So I don't really care about what's going on in the communication between the client and the server. So I think that's it for now. And yeah, let's give it a go, see what happens. Just turn these off. All right, running that, I have to compile everything first, so hang on. And now the big test. So my server is running. I have established the connection between 3 clients. They all have their input ready. So let's just pick this one. Hello all. And I actually don't see that. Interesting. Okay, so this does not work currently. Let's just see what happens. We follow it through here. So I get some input. I read it. I give it over to the handler. And I want to send a message. All right, write that message out, and that should be received on the server socket handler. Here I read a message. Did I actually get something from the server? I didn't get that. That is interesting. Okay, I'm just going to pause until I figure out what's going on here. All right, so on my server side, I start a new thread and then start it. But I don't really give it my handler. So let's see if this changes anything. So now it's actually my server socket handler that I'm running in that thread. Okay, recompiling everything. Here we go. All right, and I am starting my clients here. Third one, input. Yeah, that's good. Threads are started, connection established. Hello all. I actually get that back, and my other clients also printed out, and that is absolutely wonderful. I would expect this one to be printed out again. So let's just see what's going on here. Well, true. Handler send message. I don't know. Hello? In next line. That is interesting. Huh. Okay, that makes sense because I'm printing out. Let's pick this one. If I write hello here, I print out the input arrow thing initially, and then I receive stuff from the others. If I print out for hello, then I'm in this. No. Can I pin tab? I don't know. Doesn't work. Pinned mode. Unpin tab. Okay, there we go. Right, so it's printed out, but I'm also printing out messages I received from somewhere else. So if I send this, it prints out the input again, and then I receive the hello from the server. So it works as intended. And I do have my little chat system. I could, I don't know, also put that down here. So whenever I receive a message, prints out the input. But, yeah, doesn't matter. So I have a chat system that's sort of running, and I can. Oh, let's see what happens if I terminate one of these. Exit, and that finished, and my server did not spit out errors. And these guys, did you disappear? And that's printed out. This one obviously doesn't receive anything, and this one does, and my server, yeah, doesn't fail. So I think I made that work as intended. All right, let's stop that and go back to the slideshow. I have a few more. I do not. That was actually the last one. So this is the system that I have achieved now. I'm running my client through the main method here. It doesn't do anything other than just creating an instance of a socket client and calling the start method on it. Same thing for the server here. The sockets are handling all the communication, so only the initial connection is handled through the socket client and socket server. And I have my pool, which is responsible for broadcasting the messages. So whenever a server socket handler receives a message, it hands that message over to the pool, and the pool will loop through all connected instances, all existing instances of the server socket handler. So I think we have achieved what we set out to do. So this is a common setup. Your server will run these kind of threads, and currently I'm receiving a message, but there is an exercise about receiving different things. So this is where I would do that. If a message request type is equal to whatever, then I do one thing. Else if message request type is equal to something else, I do something else. And so that's going on here. You should check out the exercises for that. So last thing I want to do is to put this on GitHub, and you might as well see how that works, because I see some of you use GitHub in various ways, and you always mess it up. So maybe this one works. Hopefully it does for me, now that I have been bold enough to claim that you cannot figure it out. So I go to the version control system, or whatever it's short for, input into version control, share project on GitHub, and it just gives me server token, missing access token, login with username. Okay, password. Can I remember this? Incorrect. Yeah, that looks okay. Okay, and I could give it a repository name. I just call it a simple console chat. Yeah, I want to share. Sharing. Yeah, so now it asks me what do I actually want to commit, and this is also a typical step of absolute failure. So I only want to commit class files, and if you have some kind of resource, a text file or an image or whatever, you may want to commit those as well. But you do not want to commit anything about IDEA. Those are all your local settings and your IML file. So that's your IDEA setup, and I don't really know what's in it, but there's a tendency that whenever you try to commit these, it will conflict with your group mates. So I don't want anything from IDEA. I don't want anything of that. So I just have to be careful that I only commit Java files, or I'm very specific about what I'm actually committing. And that could be other types of resources, or XML files, or JavaFX files, or whatever, fXML files. I want to add that, and see what happens. GitHub login pushing. Hello. Do I have a? Apparently, I have a GitHub desktop app now. Didn't know about that. What do you know? So it's pushing to the master. I now have the version control tab down here. I can click that, and I can see I have some unversioned file. Should be. Okay, hang on. Okay, I needed to log in again. So I don't want to add that. VCS XML, I have no idea what it is. Cancel. Okay. Yeah, whatever. Successfully shared project. Right. So I have the version control down here. You can see there's some unversioned files, and I find it annoying that it keeps reminding me, hey, do you want to commit this? No, I never do. So I can just select them and right click, and I can click ignore. Right, ignore specific files, or I can ignore files matching something. I don't want any XML files, for example. Or I can ignore all files in a specific folder. I'll just ignore the specific files. And then that should have created a git ignore. Let's just see, did that work? Ignore specified file. Yeah, okay. It should create a git ignore file, project files, which will then, maybe that doesn't work. Sometimes it does. Commit. Nope. No idea. Ignore. No idea why it doesn't work. Anyway, I should be able to find it on GitHub now. GitHub, and I want to go to this /Mortensen. This is mine, my very personal own GitHub. And let's see, repositories. I think simple console chat. So now I can actually see all the code here. Wonderful. All right, that should conclude the video. I better stop here. I've been talking for a long time. So thank you for watching, or at least I hope you made it to this point. So see you around.